Navnita. I am currently pursuing BE in Electronics and Communication in Sri Venkateshwara College of Engineering. I am from 3rd semester A section, Department Electronics and Communication. Today my subject is Digital System Design using Verilog and the subject code is BEC 302. Today I am going to do the topic Implementation of Multiplexer Concept. Let us see about the introduction part. The multiplexer is also called as MUX, is a digital circuit that selects one input from multiple inputs and forwards it to a single output line based on select lines. It is widely used in communication systems, data selection and memory addressing. Here is the block diagram of N:1 multiplexer. Key features of a multiplexer. Inputs. It can have 2 to the power n input lines where n is the number of select lines. Select lines. These determine which input is routed to the output. Output. It has a single output line. For example, 4:1 multiplexer. Here we are going to give inputs. Those are I0, I1, I2 and I3. Select lines are named as S0 and S1 and output is given as Y. The relationship can be expressed as in 4:1 multiplexer is Y is equals to S1 dash S0 dash I0 plus S1 dash S0 I1 plus S1 S0 dash I2 plus S1 S0 I3. Working principle of multiplexer. Input lines provides the data to be routed. Select lines specify which input line to choose. Output. The selected input is transmitted to the output. For example, if S1 S0 is equals to I0, input of I2 is selected and appears on the output line. Let us move on to the concept of multiplexer. A multiplexer takes 2 to the power n input lines and has n select lines, 1 output line. The select lines determine which input is forwarded to the output. Implementation steps. Step 1. Using logic gates. Use AND gates to match each input with the corresponding select line combination. Combine the outputs of the AND gates with an OR gate to produce the final output. Second one, using Verilog digital design. Here is the Verilog code for the multiplexer, that is 4:1 MUX. Module MUX underscore 4:1. Inputs are given as I0, I1, I2 and I3. And select lines are S0 and S1. Output is given as Y. Assign Y is equals to not S1 ANDed with not S0 ANDed with I0 and not S1 ANDed with S0 and ANDed with I1. S1 ANDed with not S0 and ANDed with I2. S1 ANDed with S0 ANDed with I3. End module. This gives the 4:1 multiplexer. Applications of multiplexer. Data routing, sending data from multiple sources to a single destination. Control systems, selecting one of many signals for processing. Communication systems, time division multiplexing. Multiplexers, MUX can be categorized based on the number of input lines and their specific applications. Below are the common types of multiplexers. Let us see one by one. First one, 2:1 multiplexer. Second one, 4:1 multiplexer. Third one, 8:1 multiplexer. Fourth one, 18:1 multiplexer. Fifth one, cascaded multiplexers. Sixth one, multiplexer arrays. Seventh one, analog multiplexer. And the last one, digital multiplexer. Let us see one by one. First one, 2:1 multiplexer. Inputs. Here 2 is the input and 1 is the output of multiplexer. Operation for select line S is equals to 0, Y is equals to I naught. And for select line S is equals to 1 and Y is equals to I1. Here S is equals to 0 and S is equals to 1 are the two inputs. Applications for 2:1 multiplexer. Simple data selections between two inputs used in ALUs for arithmetic or logic selection. So let us see about the 4:1 multiplexer. Here inputs are given as 4, select lines are 2 and output is 1. Operation based on the 2-bit select line, one input from I0 to I3 is passed to the output. Application selecting between multiple data sources, control systems and data acquisition. Third one, 8:1 multiplexer. Inputs are 8, select lines are 3 and outputs is 1. Operation 3 select lines determines which input is passed to the output. Applications of 8:1 multiplexer. Larger data routing systems used in microprocessors for data transfer. Here is the block diagram of 8:1 multiplexer. Fourth one, 16:1 multiplexer. Inputs are 16, select lines are 4 and output is 1. Operation 4 select lines choose one of 16 inputs to forward to the output. Applications of this multiplexer are high-speed communication systems, memory addressing in computers. Here is the block diagram of 16:1 multiplexer. Here we can see the 0 to 15 inputs and which generates the only single output, that is 16:1 multiplexer, and 4 select lines are given in the block diagram. Fifth one, cascaded multiplexer. Combine smaller multiplexers to create larger ones. Example, 2 to 1 muxes can form an 8 to 1 mux. Application reduces hardware complexity in large systems, efficient data routing in modular designs. Let us move on to the multiplexer arrays. An array of multiplexers working together for parallel data handling. Applications of this multiplexer used in advanced communication systems like TDM, time division multiplexing. Seventh one, analog multiplexer. Selects one of multiple analog signals to be passed to the output. Works with continuous signals. Applications of analog multiplexer. Audio signal processing, sensor data acquisition. Digital multiplexer. Handles binary or digital signals, zeros and ones. Applications, logical operations in digital systems, computer memory management. As before we saw 8:1, 4:1 and 2:1 multiplexers. Those are all the examples of digital multiplexer. Summary of input or select relationships. Types, number of inputs, select lines. 2:1 mux. Number of inputs are 2, select lines are 1. 4:1 mux. Number of inputs are 4 and select lines are 2, which generates only single output. 8:1 mux. 8 inputs, 3 select lines and 1 output. 16:1 mux. 16 inputs, 4 select lines and single output. Thank you for watching.